Hi, welcome to the demo of Dell AppSync, the integrated copy data management solution. My name is Anuraj. I am an engineering technologist with Dell. With the release of AppSync 4.6, now AppSync supports the integrated copy data management of the Kubernetes persistent volumes coming from the Dell PowerStore array. So in this demo, we'll see how to configure the AppSync to do the integrated copy management of the PVs coming from Dell PowerStore array. Let's look into the environment here. So here I have a Kubernetes cluster, and this is a vanilla Kubernetes cluster with one control node and 3 worker node. And this Kubernetes cluster is integrated with the Dell PowerStore array, and we can see the Dell CSI driver is installed in the CSI-PowerStore namespace. Also, there is a storage class created, and this storage class will help us to carve out the block volumes from the Dell PowerStore array. Also, I created volume snapshot class, and this volume snapshot class will be used by the AppSync for creating the CSI snapshots. In this cluster, I am running a Postgres database. So let's connect to this pod and look into the tables inside that. And we can see there is a table called users, and it has 100 rows inserted into this table. In order to integrate this Kubernetes cluster with the AppSync, we need to create a service account with the required privileges. And we can find the required privileges from the AppSync installation guide. Here I already created the YAML file with the specifications to create the service account with the required privileges. So let's look into this YAML file. So here we are creating a namespace called AppSync. Then we are creating a service account in the namespace. After that, we are creating a cluster role with the required privileges. Then we are binding this cluster role to the service account by creating a cluster role binding. After that, we are creating a secret to get the service account token. Then apply this YAML file. Now all the required objects are created, and now we can get the service account token from the secret and copy this token, as we need this token to be inputted into the AppSync while integrating this Kubernetes cluster with the AppSync. Now let's go to the AppSync UI. So this is the AppSync UI, and we can go to settings, then the Kubernetes cluster. So here we can add our Kubernetes cluster. Let's go to add cluster, provide the control plane host name, the service account token, also the namespace and the bucket name. Now we can see the Kubernetes cluster is successfully integrated with the AppSync. Now let's go to the CLI, and now we can see in the AppSync namespace, the Velora got deployed by the AppSync. AppSync provides two different workflows for the copy management. One data protection and the another one is data repurposing. The main purpose of the data protection workflow is to create copies of the data with the intention to restore onto a production workload if something happened to a production workload. And please note that this data protection workflow is not intended as a replacement for a full-fledged backup solution like the Dell PPDM, as this data protection workflow in the AppSync will leverages the array-based snapshot for the copy management. The main purpose of the data repurpose workflow is to create multiple copies of the data so that this data can be used for different purposes like data mining or application testing and QA. Both the data protection workflow and the data repurposing workflow supports taking the application consistent copies of the data by using the application templates provided by the AppSync. So AppSync provides by default the application templates and also provide the option to create custom application templates. So we can see the application templates from the copy management and select the application. So here I'll select the Kubernetes cluster, and we can see the application templates. By default, AppSync provides the application template for taking application consistent copies of the Postgres server, MySQL server, MongoDB, Microsoft SQL server, and Cassandra server. These are the by default application templates, and if the user want to extend this, there's an option to create custom templates. So here you can see that I had created one custom template called Postgres. The only change I made to this custom template from the default template is to add the proper label here to match the label with my Postgres deployment in the Kubernetes cluster. Now let's go ahead and create the copies of the Postgres application running on the Kubernetes cluster. So let's go to the Kubernetes cluster. And here we can see our Kubernetes cluster, and go to this cluster, and here we can see all the namespaces. And here let's select our namespace, which is the Postgres namespace, and now we can create a copy of this Postgres namespace. Let's go to create a copy with a plan. Then as we discussed before, there is two different workflows for creating this copy. So there is a data protection copy and there is a data repurposing copy. So here we'll select the data repurposing copy. So let's go to the data repurposing. So here the AppSync will automatically select the appropriate application template based on the label. So we already matched the label of my Postgres application template with the Postgres application deployed on the Kubernetes cluster. So AppSync will automatically pick that application template. Click next. So here we will not mount the first generation copy, and okay, we'll also create a second generation copy. So we'll select yes here, then click next. Run it now. And for the second generation copy, I'll give a name as dev. So because I'm going to use this as a development copy, and it is possible that I can mount this copy while the creation itself, or we can mount it later. So here I'll prefer to mount it later. So we'll not be mounting during the creation. So let's click next. Now AppSync is creating the repurposing copy. Before creating the first generation copy, AppSync will use the application template to put the Postgres application into backup mode to get an application consistent copy of the Postgres application. After the first generation, it is creating the second generation copy. Now both the copies are successfully created. So now let's look into the copies created. So go to the namespace and we can see there is a first generation copy created and there is also a second generation copy created. So let's mount the second generation copy onto the same Kubernetes cluster into a different namespace for the development purpose. So select the second generation copy, then mount copy, select the Kubernetes cluster. So here we'll mount onto the same Kubernetes cluster. Enable the namespace mapping so that the copy will be mounted onto a new namespace, the PostgreSQL-dev. Now we'll wait for the copy to be mounted. Now the copy is successfully mounted into a new namespace. Now we can see our development namespace got created, and let's verify the Postgres application is running inside this namespace. So we can see that our Postgres application is running inside the development namespace. So we can verify the database content also here. So let's connect to this pod and verify the data inside the database. Now we can see the copy also contain the exact same data as the production. Now let's see the PVs. So we can see there is 3 PV, one is the actual PV and 2 are the copies. Also let's verify the snapshot. So we can see AppSync created 2 snapshots. One snapshot is the first generation snapshot and the other one is the second generation snapshot. We can verify the volume topology from the PowerStore console. So in the PowerStore console, select the volume, go to more action, view topology. Here we can see the entire snapshot topology of the volume. So we can see on the volume there is a snapshot created, and this is the first generation snapshot. And from the first generation snapshot, we create another snapshot, and that is the second generation snapshot. With the help of the AppSync, we can do this entire operation with a few clicks in the UI. This concludes this demo. Thank you for watching.